Hello guys, welcome to my class number 4 on topic of integration, and subtopic in this class will be integration of exponential function. I'm Engineer Goodluck, and you can contact me through my email goodluck.daudk@gmail.com, and I'm from Tanzania. To understand an integration of exponential function, first we must consider the idea of differentiation of exponential function. For example, if of x is equal to e raised to x, then let's find its first derivative. It means f dash of x. So when we differentiate f of x with respect to x, what we get is e raised to x. When you multiply by d of x both sides, in this case d of x will cancel with this one, and at this side d of x will be introduced. So we remain with d f of x is equal to e raised to x d of x. Introduce integral sign both sides. Integral of d f of x, integral of e, this one. So when we introduce the integral both sides, we get this results. But the integral of df of x, this integral and the derivative of f of x cancel, remains with f of x is equal to integral of e raised to x dx. So this implies that the integral of e raised to x dx is equal to f of x plus constant, and f of x is equal to e raised to x. Therefore, we conclude integral of e of x is equal to e of x plus c. This is the same as when we differentiate e of x, we get the same result, and when we integrate e of x, we get the same result plus a constant. Okay, so what we can do, if f dash of x, this one, has a coefficient a, this is a coefficient 1. So what will we do when we have a coefficient a in front of variable x? In this case, we use substitution method. We let a of x is equal to any variable. So we let ax is equal to any variable. Example, obtain f of x from its first derivative, which is equal to e raised to bx plus 1 bracket. So to get this, as we saw earlier, we must let this power is equal to any variable. It means we must let bx plus 1 is equal to any variable. Okay, we know in order to get f of x from f dash of x, we apply an integral. So f of x is equal to f dash of x dx is equal to integral of e bx plus 1 brackets dx. So we let bx plus 1 is equal to u. U is equal to bx plus 1. When we differentiate du with respect to x, we get du dx is equal to b. So when we substitute where there is bx plus 1, we put u. Therefore, in this case, bx plus 1 will be represented by u, and dx will be represented by du over b. So we have integral of e raised to u dx will be du over b. So b is a constant we get out of integral sign. We remain with integral of e raised to u du. And we know integral of e raised to u du is equal to e raised to u. So we have e raised to u divided by b plus a constant. What is the value of u is equal to bx plus 1. When you substitute back, you get e raised to bx plus 1 over b plus c. Okay, let's look on example number 2. Obtain f of x from f dash of x is equal to a raised to x. In this case, we have this kind of expression, a raised to x, not e raised to x. So we know in order to get f of x from f dash of x, we apply an integral sign. And when you substitute the value of f dash of x, we have this expressions. But we let this a raised to x is equal to y. We let y is equal to a raised to x. To simplify this expression, we use algebra technique. When you look at this, we can differentiate or we can integrate this exponential. Because when we want to integrate and we think what function will give this result when we differentiate, there is no such kind of function. So to simplify the method of integration, we use the technique of letting y is equal to a raised to x, and we apply algebra technique in order to get a simple expression. So when we apply ln, it becomes ln of y is equal to x become in this position, and they will remain with ln of a. And ln of a, mind you, is a constant. So when we differentiate this such of expression, we get dy over y. At this position, we get dy over y is equal to constant ln of a dx. So when I move this y at the side, it means y dx, and ln of a at this side, it means dy over ln of a. I get this expression. Dy over ln of a is equal to y dx. But we know y is equal to ax plus. We know y is equal to a raised to ax. Then we must introduce integral sign both sides. When we introduce the integral sign on this side and this side, we have the following expression. Ln of a is a constant, and the derivative of y, ln of a is a constant, has no effect on this integral, and the integral cancel with the derivative of I. So here we remain with y over ln of a and plus constant. In this side, y is equal to a raised to x. So we remain with integral of a raised to x dx. but y is equal to a raised to x. So when we introduce integral to these expressions, both sides, integral of y dx and integral of dy over ln of a. We know ln of a is a constant, we'll get out of integral, and the integral sign will cancel with dy. So what we get is y over ln of a plus constant is equal to integral of y. What is y? Y is a raised to x. So we get, in this case, we get integral of a raised to x dx. Therefore, integral of ax dx is equal to y, which is a raised to x divided by ln of a plus constant. And this is a general result for integral of a raised to x dx. Thank you for listening. See you in next class number 5.